Hello, everyone. This session, we will talk about hydration, Iceland. We will not drink water, but yes, we will talk about front end and a little bit back end. So give a warm welcome to Matheus. The stage is yours.
Bonjour, je m'appelle Matheus, and that's pretty much all the French I have for now. But yeah, I'm Matheus Albuquerque, and we're here to discuss islands, hydration, streaming, resumability, and a lot of other stuff related to how you render stuff in the browser. And by the way, if some parts of the presentation feel really dense, you're probably going to find this emoji. It means let's have discussions afterwards. So this is what we want to cover today. We want to talk a little bit about the past and the future of things. And then, of course, we'll dive into islands. We'll talk about resumability. We'll talk about streaming SSR and how it comes combined with selective hydration in React 18. Of course, it's impossible not to talk about server components these days, so we'll also cover them. And we'll draft a few closing thoughts on top of everything. And I also want to know a little bit about you, so please raise your hands. You all work with front-end? Who here is doing? Okay, great. Who's doing React? Okay, most of you. Angular? Most of you too? Okay. Vue? Okay, everyone's doing all of these. Cool. So I guess it all starts with this question, like how and where we want to render something. Because these days, we can do things on a web server, of course, but we can also render things in build time via a build server. We can also render things on the client, the browser, of course, and we also have edge rendering also. Not to mention, we have different ways of doing things. We can render things all at once, or we can go partially or progressively. Not to mention a lot of following up questions we get, like, how do you handle navigation? Is that on the server? Do you do an MPA or an SPA? Also, what is exactly that you execute upon loading? Or when do you do data fetching? How do you handle data fetching? And last but not least, what do you include in your model? Or what do you serialize and send over the wire? So it's just a bunch of questions. And even when is that your app become interactive? Because we do have a few metrics, some core web vitals like first input delay or time to interactive. And more recently, we got INP as well. That is the new thing to discuss interaction. And that's just a bunch of questions. And from time to time, I wonder, how did we get here in the first place? Because I remember back in 2015, 16, we were discussing the JavaScript fatigue, and the question at the time was, do I want to go with React, Angular, or Vue? So these days, we have a lot more of choice. So I think it takes a little bit of a trip back in time to start talking about this, and let's talk about the past, and let's talk about the beginning of the web. And when those servers, they started in the Swiss basements, basically, all they had to do was just get you static HTML, and if you're lucky, you had some images, and that was pretty much it. And it's insane, the research that we have these days that shows how things just got more complex. For example, in the past decade, the median size for a desktop web page grew by 388%. And if you talk about mobile, that's even worse. We're talking 1,200% increase. Okay, going fast forward in time to the year of 1995, it was an important year. Actually, we had a bunch of milestones that basically changed the way how technology happened. And I'm talking, of course, about the release of PHP 1.0. That was supposed to be, but no, but seriously, those CGI scripting languages, they were great because I'm talking like Perl, PHP, etc. Basically, they allowed us developers to bring data from a database or even real-time data and ship it into HTML. And for the first time, we were doing dynamic information. And the reason why these were on the servers is that the server was the powerful part of the network at the time. So all the browser had to do was to get information, interpret a document, and display it. So you didn't have a lot of interaction. But then, fast forward in time, JavaScript evolved as a language, and the web evolved as a platform, browsers, everything. And we could do fun things directly on the client. And that's when we started to hear a lot about single-page apps and client-side rendering. And client-side rendering was actually great because we didn't have to keep coming back to the server just to do navigation, for example. And also we could cache a lot of stuff. We could cache our HTML, our core JavaScript models, core CSS, etc. And as the web became more and more interactive, SPA sort of became the default thing to do. But then we faced a gotcha moment, like suddenly we had to worry about some parts of performance that we didn't have before, and we were concerned about how our bundles would be downloaded and executed by, for example, a user in the middle of the city center with a not so great data connection. And we decided to solve this by going back to the server. But this time we were doing this thing called SSR, and as Rick, he is one of the core maintainers of React, he points really well. With SSR, back in the day, we're not doing like what PHP or Ruby were doing. So actually, SSR happened to be a not so great name. And some people even suggested that SSR should be client-side, server-side rendering, because with SSR, we were just rendering the first render in the server. But still, SSR was great, because once the HTML was ready to be displayed, it happened almost when the page was loaded, so you had great performance. Also, less things had to happen in the browser, so you had more compatibility. And unfortunately, we still had a problem with interaction. So that's when we started to talk about hydration. So doing a little bit of an intermission on the topic of hydration, if you're not familiar, I love this definition by Mishko, the creator of Angular and Quick, where he says that hydration is the process of attaching behavior to declarative content to make it interactive. And hydration comes with a few challenges, because, of course, you have to associate the DOM elements with their corresponding event handlers. That's pretty much hydration. But also, once a user triggers one of these events, you have to update the application state. And once you update the application state, you need to go through and recreate the whole component hierarchy. Of course, you can come up with approaches to improve that and etc. By the way, there's this really interesting post by Ryan from Solid, where he explains a couple of challenges when it comes to hydration. But also, hydration comes with a few questions if you're building a framework, for example. Do you send the whole JavaScript on every request, or you optimize it somehow by sending depending on the route? Also, do you do hydration top-down your component tree? And if you do that, how expensive is that? And last but not least, how do you orchestrate that in a great developer experience, and how are your developers end up going to orchestrate that? Last but not least, hydration also comes with a few issues. And this is probably the most popular of them. It's called the uncanny valley. And it's basically so you have your initial request, you got your HTML, and the view is painted. But then it's going to take a few more until you have the JavaScript, and that JavaScript is parsed and executed, and etc. So the uncanny valley is this moment where you don't have interaction, but you can see things. And if you break down some of these steps, a lot of bad things can happen. So first you get HTML, and that's usually fast, of course. But then when you're downloading JavaScript, that can go slow, depending, for example, on the network conditions of your users. And then you have to parse and execute the JavaScript. And that can also go slow depending on the device they have and also the amount of JavaScript you're sending them. And last but not least, your application has to recover state and bind the event listeners. And that can also go slow depending, for example, on the amount of done nodes you have to go through and the amount of references you need to rebind to those listeners. By the way, there's another post by Mishko about the issues with hydration and etc. But the fact is, throughout the years, we've been trying to address the different problems with hydration, and islands were one of them. So islands, we started to hear a lot about them back in 2020 with this post by Jason Miller. He is the creator of React and a lot of other cool open source stuff. But it's crazy because if we check previous posts in time, we'll find this one that's called declarative JS components with vloader.js. And this post was written back in 2013, and it was talking about the idea of attaching JavaScript behavior to a chunk of HTML, which is kind of what islands do. So there's this cool definition that says that islands are a component-based architecture that suggests a compartmentalized feel of the page with static and dynamic islands. So if we break that down, basically, islands are about having selectively enhanced, progressively enhanced bits of server-side rendered HTML with client-side JavaScript. And you end up with small, focused chunks of interactivity within those server-rendered web pages. And you kind of have this mind shift where we used to have, for example, one single app in control of the full rendering to having what's like multiple entry points. The other thing is that the scripts for the islands, they can be delivered and hydrated independently, which basically allows the rest of your page to be just a static HTML. And that's exactly what the output of each island is, progressively enhanced HTML. But with islands, as opposed to just progressive enhancement in general, you have more specificity on how this process occurs. So it's better if we can visualize. So here's one of the classical examples around it, where we have a blog, and we have our layout, we have the title of the post, we have the content of the post, and at the bottom, we got some buttons for sharing on social media and also for leaving comments. So if we were to model that with islands, these could be server-side rendered. So the layout can be server-side rendered. The title and the content can be too, because in this scenario, there's no interaction with it. They can be just static HTML. And then we would have two islands, the comments and the social buttons. So those would act as micro apps within that, where we would have the SSR. They would be server-side rendered, but they would ship with their own hydration scripts. And nowadays, we have a bunch of different implementations of islands. So you can find standalone implementations like Astro, Marco, and others. And you can do islands with Preact, with Solid.js, Svelte, and many others. And Marco is an interesting thing to be discussed, because Marco has been around since 2014. It was open source a little bit after that. But Marco had this very, very interesting combo of having streaming rendering with automatic partial hydration and a great compiler that would basically generate optimized code depending on whether it would run on the server or on the client. And it also shipped with the automatic partial hydration that would allow the interactive components of your page to hydrate themselves. And of course, the hydration code would be only shipped for those interactive components. Years later, we got Astro, and Astro got really popular. So Astro was out in 2021. And again, it had a very, very interesting combination. So it was born around the idea of, by default, let's just ship 0 JavaScript and go from there. Also, every island in Astro can be loaded in parallel. And Astro is also a multi-framework. So Astro allows you to build islands with different solutions like React, Preact, Svelte, and others. And one thing I do love about the DX of Astro is that it basically allows you to specify the loading strategy for your islands. So let's say I'm using this React component in JSX inside Astro. I can use their directives to do something like this. So I can say, okay, hydrate this component upon loading, or maybe when the browser is idle, or when it gets visible because maybe it's below the fold. So you have different options for defining the hydration strategy for your component. And islands, as a general, they have some common use cases out there. One of them, for example, is an e-commerce page. So let's say you have a product page, and a lot of your product, like the title, the description, etc., all of that can be server-side rendered because it's static. But then the search bar, the product carousels, all of that need interactions, those could be islands. And any kind of app that generates any report or something like this, let's say an internet banking. So the details of the account and the list of transactions, that kind of thing, this can be static, but filtering or searching, those could be separate islands that would ship separately. So wrapping up islands, it has a few great things. First, you're reducing the amount of JavaScript shipped to the client, and that's great. Because of that, you get some better metrics like TTI. And from a user perspective, what you got is that the key content of the page is shipped faster. And because you're doing SSR in the end, you also get some of the benefits of SSR, like, for example, having SEO. Where I personally see islands as a misfit is, depending on the amount of interaction you have in your page, you might end up with just a bunch of islands, and then you might end up shipping just as much JavaScript you would if you were not using islands from the very beginning. Also, in 2021, we started talking about resumability. And I think that a good way to intro resumability is if we see that a huge part of what we have in our landscape for SSR today is built around frameworks that were not initially meant for that. So if we go back in time to 2011, 2012, 2013, we got a bunch of these experiments, like this one that got really famous by Airbnb. People were grabbing frameworks like Angular, React, in this case Backbone, and finding ways to server-side render these in Node. But what if they were built from scratch with the idea of SSR in the first place? In 2011, we had this language called Oppa. And Oppa is very interesting, and not a lot of people know about it because it went way beyond just partial hydration. So with Oppa, you would basically write your programs, and it would have a compiler that would slice client and server concerns for you. Years later, we got Meteor, which had some of that idea in mind, and it got a lot of traction back at the time. And then we got Quick in 2021. And Quick brought this idea of resumability, which is about pausing the execution on the server and resuming it on the client without having to replay and download all of the application logic. So as the name suggests, you do some work on the server, you pause and you resume where you left off, and Quick is going to use what happened during the execution on the server to avoid extra work in the browser. And it does attach those global event listeners at start time, but it only runs them when it's necessary upon interaction. So if you put that side by side with traditional hydration, and I'm not talking like partial or progressive, traditional hydration, we have this. First, with traditional hydration, the event handler creation happens when the event is triggered. So it's an eager approach, before the event is triggered, sorry. Also, all the possible event listeners are added. So it's also an speculative approach, because you might have event listeners that are never triggered. Also, you have clients redoing work that happened on the server. And last but not least, the framework implementing that needs to download and execute the components to figure out their hierarchy. With resumability, we have an opposite approach. So everything is lazy, so the event handler creation happens after those are triggered. Also, only those that are triggered get created, so it's as needed. And the client doesn't redo what happened on the server because it just deserializes information sent by the server, which of course requires a lot of information to be properly serialized into the HTML. So if we think about the flow, you start, of course, by displaying HTML, and then you are resuming the state by deserializing information that you got, and that information includes the event handlers, the state of the app, and also the hierarchy of the components. And then magic, you got interaction. And you're probably wondering how that compares to islands or some other improvements around hydration. So basically, with islands, we cut some of the things where we don't have, for example, extra things needing hydration, etc. But with islands, you usually still have the client redoing work that happened on the server. And also, the things they happen at island level Whereas with resumability, you got way more granularity about what's sent over the wire, and you don't have client redoing work. If you're interested, there's this live stream by Ryan from Solid and Mishko. It's like a few hours where they ideate through the process of creating quick and resumability. But that's what's great about resumability. You tend to have better startup performance, and of course, because of the whole combo of resumability shipped with quick, you also have better rendering performance because only what's changed is re-rendered. And you also get fine-grained lace loading and progressive interactivity. So it's a bunch of cool ideas all together. What I personally don't think might not be great is that first, it's an official recommendation that you preload your critical interactions so that the user doesn't have to wait for an event handler to be downloaded after they click. But the thing is, depending on the amount of critical interactions you have, then you might have to preload a bunch of stuff. So it depends on your case, of course. And the second thing is the only option for you to leverage resumability as it is these days is quick. So because of that, you don't have a lot of discussions or cases outside of the builder, of builder.io or the quick community. And this concerns me a bit. But still, I think that quick is a great example of outside of the box thinking to address a problem like hydration. We also got some, throughout the years, we got people thinking other ways to address other problems that would also improve performance, and incremental static generation is one of them. And it's not focused, for example, in hydration or any of that. It's like an evolution of the gem stack that kind of tries to address at the same time some problems with client-side rendering and server-side rendering. And it basically allows you to update static content without a full rebuild of your page. And it was made very popular by the Next community. So basically, that's the advantage of ISR. You have the flexibility to choose, for example, for having faster builds or caching more. And with Next, it basically works when you define within your get static props. You can define this revalidate option. Here I'm using 60, for example. So by doing so, Next will attempt to regenerate that page when a new request comes in, or at most every 60 seconds. And that's the flow, for example. So here, the page is then generated on the first request, of course. And then here, it's served from the cache. So unlike SSR, when a visitor comes in, they don't have to wait from the data fetching. It will just be shipped whatever's on the cache. And then once the data is resolved, it's going to generate a new version of the thing, and of course, update the cache and serve it to the new user, to the user. So even when revalidating, the visitor first receives the cached version. So if you're familiar with SRR or state while revalidate, that's pretty much it. And again, some cases around it are, for example, when you have static content but lots of pages. So imagine a blog, but not a blog where you have like few dozens of posts, but imagine like hundreds or even thousands. So a new post, if you're pushing a new post, it's not great that you have to wait for a whole rebuild of all of your posts just to ship something new. And also for an e-commerce, for example. So a lot of people these days are building storefronts with a lot of static data. And if you have thousands of products, you're going to have like huge CI builds. So ISR is very convenient here. And that's where it's great. It brings all the benefits from static generation, and it helps you when you have dynamic content that you want to statically generate that. But of course, it might bring server costs depending on like your process. And because of that, a few moments later, they came up with on-demand ISR. So on-demand ISR basically allowed you to do all of that, but just, for example, upon triggering a webhook or something like that. And then you got all the benefits from static generation and dynamic content. And you could have more control, for example, not over your server builds. Another thing interesting that happened, it started to happen back in 2017, but it got more traction in 2022, was this whole combination of streaming SSR and selective hydration. So you probably remember when React 16 came out, you would see a lot of, depending on the minor, of course, but people were talking about hooks, some people were talking about suspense, and some people were even talking about the new context API shipped with 16.3. But not a lot of people were talking about streaming server-side rendering that was first shipped with React 16. You did have some cases and etc., but it only started to get more traction last year when it was announced alongside selective hydration as part of the concurrent React umbrella. So for us to get a better grasp on things, it's good to look how it was before. So before React 18, the hydration could only begin after the entire data was fetched and rendered on the server. So users couldn't interact with your page until the HTML, the hydration was complete for that whole page. And because of that, the parts of your apps that were fast, they ended up having to wait for the slow ones so that everything could be shipped. So it looked like this. All of these are sequential and blocking. So it would fetch your data on your server, you would render the HTML on the server, and then you got your first byte, and then you would load all the code on the client, and you got your FCP, and then after it was hydrated, you could get your TTI. With streaming SSR and selective hydration, this turns into this. And basically, it's done using pipe to node stream, which was shipped with React on 18, and create root and suspense. And by doing so, React now prioritizes hydrating the parts of the app that the user interacted with before the rest. And also, because it's part of the concurrent React umbrella, the components, they can become interactive faster by allowing the browser to do other work at the same time as hydration via concurrency. And the bottom line is that React no longer has to wait for those huge components to load so that it can continue streaming HTML for the rest of your page. And also, when those huge parts, they become available, they will be streamed and inserted in the right place via script tag. And a lot of companies, they even build interesting cases. For example, I recommend you check this post by Vercel. They improved some of their core web vitals, including INP, by redoing the Next.js website and leveraging streaming SSR and selective hydration. And then we get to talk about server components. And it's crazy because we mostly started to hear about them in late 2020. But if you've been following the discussions and the RFCs and etc., that's pretty much what before was React Flight and first React Flight. But then, and you had a lot of these discussions going on in 2017, 2018, and etc. But then it was late 2020, and we got this blog post by Dan introducing zero bundle size React server components. And after that, and especially when Next 13 shipped with the app router, there was a bunch of discussions on Twitter and a lot of opinions, and the whole React community was like, okay, we have server components, we have suspense, we have transitions, how do all of these piece together, when are they gonna ship, and etc. And what exactly are them? So one of the best ways I like to see server components is as if you had ahead of time React rendering. That can be, for example, during build or even on the server. But it's not only that. It's a whole new way of routing your app that goes in direct integrated with the way you fetch your data and even with your bundling layer. And server components sometimes are not great naming because it's not necessarily related to SSR or even to how you do hydration. Now that we discussed islands, a lot of people don't notice, but a lot of things in server components are almost identical to how islands work. But if you've seen the use client thing on Next 13 app router, use client there is marking a boundary between two module graphs. Because in Astro, for example, we have the React part and we have the Astro part, and that's clearly defined. With server components, we are the ones who have to mark this boundary, and use client is there for it. And also with RSC, basically each component can decide whether to be a server component or to stick being server plus client. And in my opinion, server components brings three great things. The first and most obvious is that the code for server components is never shipped to the clients, and as opposed to a lot of SSR implementations we have these days where we still have a lot of things being bundled and sent over the wire. The second thing is, a lot of people see this as a bad thing, but you get access to the backend from anywhere within the tree. And it's not like we're not doing this these days. So with Next, for example, we have the page methods. We have, for example, get server-side props and that. But that's limited to page level. With server components, you can do similar, but from anywhere within the tree. And last but not least, and that's my favorite one, is that those can be refetched while maintaining client-side state inside of the tree. So think, for example, of a search bar that you can not only do navigation, but you can re-render on the server, and you can maintain, for example, the focus or the selection state, hover state, that kind of thing. So then came up with a very interesting example. So this is before server components, and you can see that as he navigates, he just loses this state in the search bar component. And this is the exact same code, but shipped with server components. Now you can type anything into the input, and the state is no longer lost between the navigation. What I don't think is great, though, about server components is that I'm particularly concerned in certain cases about the amount of things that are going to be sent along the wire, depending on the re-renders. And also, a lot of things, even though they are sold out there as a stable, you can see that a lot of things within server components are still experimental. So it also concerns me the amount of orchestration needed from framework side, but also from us app developers using implementations of server components. And yeah, the whole thing is still experimental, and you don't have a lot of options to use server components if you're not using Next. So kind of the same problem with Resumability and Quick. But one thing I do love about the discussion on server components is that it reminds me of this when Mishko said that this whole thing of collocating clients and server code altogether would be one of the things we wanted to explore the most in the coming years. And when I first saw server components implemented in the app router, I thought a lot about this thing called Jaxer. Has anyone ever heard about Jaxer? Cool. So Jaxer was there back in 2008, so I'm talking more than a decade ago. And basically, Jaxer allowed you to have this. You would have single file apps that with logic that could run on the browser or both on browser on the server. And the script tags even had this run attribute where you could mark both or just server. And it's amazing if you put side by side the demos, even the ones that are using database connections and etc. And you have like 15 years distance between these two code samples. But anyways, I think that not only me, but a lot of us in the community, and even the ones building server components, we all need to get a better grasp on the idea. There's this session by a friend of mine where he basically builds from scratch a very tiny implementation of server components. And also there's a bunch of interesting live sessions conducted by Kent, Dan, and others on the topic, not to mention side projects like Waku. So Waku is created by Daishi Kato, and Daishi is one of the creators of Zustand and other great state management libraries by Parmandres. And he's building for a couple of months now his own implementation of server components, and he's been documenting the whole process. So it's definitely something to watch. And a lot of people from other communities are doing something similar. So we have Strike as an implementation of server components using Go, and even in OCaml. Not to mention projects like Blink, which are, Blink is also by 10stack, so if you're familiar with 10stack query or 10stack table or all of these. So Blink it's not an implementation of server components per se, but it's a very, very interesting project for you to see client versus server code collocation, that kind of thing. And then we got the Edge. And we started to hear about the edge a lot back in 2017, especially the terms of edge functions and edge first frameworks. So basically, the common definition out there is that edge functions allow you to serve content from the CDN server closest to the user. So for example, if you compare that to the serverless, usually those serverless functions, they are deployed to a very specific region, and they would run in this region regardless of the origin of the initiator. With edge functions, though, they tend to run as close as possible to the requester, and they run on this what's called the distributed edge server. And not only the edge functions, but the whole idea of the edge is that you're thinking a lot about bringing computing closer to the source of data and having fewer processors in the cloud. And by doing so, you're basically minimizing the distance, the need for long-distance communications between client and server. And then, of course, you get less latency. And in the front-end community, we started to hear a lot about them back in 2017, because that's when Cloudflare announced Workers. And Workers are an edge network, but they're also a reduced JavaScript runtime. And you will probably notice that a lot of those edge options out there, they always ship with their own JavaScript runtimes. So Dino, for example, also has edge, and they also ship with Dino runtime. And a good way to see that is this study conducted by, I think it was Dino. So basically, they compare the time to first byte from this app that in different locations, of course, and served by a traditional Heroku deployment. And then they compare with Dino distributed edge network. And you can see that regardless of the origin, of course, the time to first byte was better. And what you noticed from 2021, 2022 onwards was that edge function support was rolled out for pretty much any of Meta framework we have over there in the past couple of months. And for example, today, depending, of course, on what you run in your app, but you can deploy a Next.js app to Versal Edge Network, for example, or Netlify, etc. And wow, we kind of rushed through a lot of concepts. We discussed hydration, streaming SSR, resumability, islands, different approaches to hydration like selective hydration, how to optimize the static stuff via ISG. We discussed the issues with SPAs and client-side rendering. We went very, very briefly through edge rendering. And to be honest, we could be here for hours. We could explore more, for example, different approaches to static rendering. There's this new View Transitions API, and for example, Astro has rolled out support for transitions using that. There's a bunch of other stuff that's related to progressive hydration or partial hydration, etc. But we don't have the whole day, so let's talk a little bit about the future. So I think that more than ever, we'll be reflecting on this whole thing of server versus client navigation. So we'll talk a lot about routing, and we'll revisit a lot this community decision of shifting from MPAs to SPAs and whether that was a good idea or not, and different approaches to do that. By the way, there's this, I know I'm quoting a lot of Ryan here, but there's live stream by him that's like 5 hours on the topic. It's really interesting if you have spare 5 hours. I think that we'll also be revisiting a lot of the problems of hydration and coming up with new approaches to it. Islands was one of them. Resumability was like really mind-blowing. So we're revisiting whether it's pure overhead or not, and etc. We'll also think a lot about 0 kilobytes JavaScript and whether this is a goal we want to have as a community or not. And then, of course, talk a lot about code extraction, as you mentioned. And by the way, back in 2019, referring to React server components, Dan was basically saying that the next wave of techniques and technologies was not about putting everything on the client or on the server, but actually letting you move code in between without friction. And have you seen this import attributes thing? It's an ECMA proposal, and TypeScript in 5.3, I guess, has just shipped support for it too, which is very interesting. And when I saw that, I thought, okay, if using this, we can do, for example, import JSON from this file with type JSON, perhaps in the future, we'll also be able to import component and then pass with type client or with type both. I don't know, I like to ramble and think about that. And more than ever, we'll have posts and talks on why a given technology is going to be the future. So I promise this is going to be fast, a few closing thoughts on top of all of that. As you probably noticed, when you find a solution to your problem, you're just changing, most likely, the problem that you have. And while a lot of these technologies, they might seem like they're competing, actually they're complementary, because they don't solve the same issue completely. They just focus on different parts of the problem. So if you break down, for example, islands, you're reducing the JavaScript footprint by basically explicitly saying what needs to be hydrated or not and go to the client. And islands are really optimal at solving problems with data serialization, etc. Server components, they're standing the idea of islands, and actually server components are probably the only solution that properly accounts for client state while doing navigation on the client. And then you got resumability that shifts completely the focus. So instead of reducing the amount that it's hydrating, you're looking to remove the execution cost of hydration. And of course, in an analogous way, you will see that the same pattern can be good or bad depending on your case. So that's why, for example, you are going to find a lot of large enterprise scale apps or huge monoliths where a certain part is rendered with one strategy and another part with another strategy, or even different routes. That's why I love this post by Jason. It's called Application Holotypes. And in this post, he basically promotes another way of seeing things. So he explores what kinds of apps you can build, like a social network, a game, or an e-commerce. And then he goes like, okay, which things you have to account for that specific kind of app. And then Ryan expands this idea of application holotypes by explicitly saying, okay, if you're building a portfolio or a storefront or a social network, how do you want to handle hydration for that? How do you want to handle routing? How do you want to handle the interaction of that? Another thing is, there's a bunch of memes like that about server components. And I think that it's kind of easy to think that we're just going back to render HTML on the server like we did back in the day. But I think that these days the boundaries are really, really different. So with PHP and Rails, the boundary pretty much stopped at the server. It would render things and would take form submissions. And then in 2014, Marcus tried to push that boundary by encapsulating more stuff. But I guess most of us were just busy building SPAs to notice that. And then more recently, we got efforts from the PHP community, the Ruby community, the Elixir community with things like Hotwire, Livewire, etc. And these are pretty much the backend community trying to expand that boundary, but primarily using backend technologies. I think that server components and Quick are basically the front-end tools trying to do the same. And I think it's a very, very interesting effort. You're basically expounding the boundary while fully respecting what's client and what's server concerns, and I think it's great to watch. As you probably noticed, software development is always going through cycles. And it's important that a lot of the things happening in the front-end community, we're not the first ones trying that. So it's important that we think, what's different now? And what was a great idea in the past but was just lost throughout the years. So 2 examples of that are Andrew Clark back in 2018. He was showing how how React Fiber and the whole reconciliation algorithm borrows inspiration from a technique called double buffering that has been in the game industry for decades. And then years later, Dan Abramov was showing how a lot of the cool things that React teams started playing around 2018, 19, 2020, Marco was doing those back in 2014. And he links to this post of async fragments, and this post is from 2014. And Marco team even had cool sessions on the topic at the time. And if you explore that post, you'll see that they linked to a post from back in 2005. So for me, that's just insane. And all of that is insane. All of that is incredibly complex, and it should be, because we're addressing like really complex challenges. If you remember, back in 2010, it wasn't so different. We had responsive design, and we were trying to address in the front end an incredible amount of resolutions, screen sizes, everything that was just unpredictable. This is probably the last one. You know what they say, that a picture is worth 1,000 words, so I wanted to close with a picture. This was me about a decade ago, speaking at an iOS meetup, and I used to do iOS, and I was playing with Ionic, and I was super hyped about Ionic. So I was basically saying, stop building native apps, because Ionic and Angular are going to be the future of mobile. And native Android is still here, native iOS is still here. So I was kind of wrong. And that's it. Don't always trust all of these speculations and future predictions, because the cliche is true. There's no such a thing as a silver bullet. So it's important that you understand your core metrics and you correlate those with your business stuff, conversion rates, bounce rates, etc. Those are important and combined to your Lighthouse scores. So don't always just go with cool Lighthouse scores you see on Twitter. This is me. You can find me everywhere as White Combinator. I'm a senior software engineer at a company called Medallia. I mentor front-end students at Tech Labs, and I'm a GD in web/performance. In this QR code, you can find the slides for this session and a lot of other sessions I have about internals of React, performance optimization, etc. You can also find my session on the DevFest Nantes page, so you can leave feedback on what you liked. But if you didn't like, just tell me. Don't leave it there. Kidding. Merci beaucoup. And that's all. If you have questions, I'm going to be around for the whole day. Find me in the after party. Find me online, etc. Thank you so much for having me.